All right, we're going to look at the polynomial functions homework. So looking at number 1, this is really nice because it is all factored for us, so it will help us to find the zeros very easily. But if we want to find out the end behavior, we're going to have to think about all of the terms that would come out if this were to be multiplied. So I know that we have the negative 0.1, but then out of the x minus 5, that would give us an x term. Out of the x plus 2 squared, that's x plus 2, we're going to get an x squared term. And then out of the x minus 1 to the third, that's going to get us an x cubed term. So altogether, we're looking at negative 0.1 x to the 6th. There's really an invisible 1 on there, so a total of 6 x's. Now, we know our end behavior then is going to be both down, and that's because we are in even degree. And we have a negative lead coefficient. So in my head, I kind of think about that as like a negative x squared. We imagine it looking like that guy. All right, so now the x-intercepts are going to be, we set each factor equal to 0. So we have x minus 5 equals 0, x plus 2 equal to 0, and x minus 1 equal to 0. That's going to get us x equals a 5, a negative 2, and a 1. And then we need to list the actual intercepts. We'd write them as points: 5, 0, negative 2, 0, and 1, 0. Okay, so again, if we list just zeros, we could write them x equals. And then if we want to write them as intercepts, those are really points. Then it asks for the multiplicities of all the zeros. So the multiplicities, I'm going to go back up here and I'll just fill it in. Our multiplicities will be the 5. X minus 5 happened only one time. The negative 2, that happened 2 times. And the 1 happened 3 times. And what we're looking at is the number of times that its factor appeared. All right, so then we have the y-intercept. That's when we let x equal 0. So we're going to plug a 0 in there. We're going to get negative 0.1 times 0 minus 5, 0 plus 2 squared, and 0 minus 1 cubed. And so we're going to have negative 0.1. We'll have a negative 5, a 2 squared, and a negative 1 to the third. That's negative 0.1 times negative 5 times 4 times negative 1. If we multiply that all together, we'll get a negative 2. Take a check on that. And so what we're saying then is that our y-intercept is 0, negative 2. So then we're going to put that all into the graph. So I'll go start with that y-intercept, 0, negative 2. My end behavior, I know we're both pointed downward, so I just kind of draw that off to the end because that's my goal, is to reach those. I have to touch at 5, 0, negative 2, 0, and 1, 0. Now those are the only places where I can touch the graph. Now those multiplicities help me determine if I'm going to bounce or go through. So kind of going back up here, a 1 is odd, so that's going to be a through. The 2 here, that's even, so that's a bounce. And then that 3 for that multiplicity would also make me have a through. So at 5, let's actually go backwards here. At negative 2, I'm going to bounce, so I'm going to connect up there, bounce. I have nowhere else to go. I can't go through the x-axis until I cross through that y-intercept, so I'm going to cross there. Then I'm going to go up to the 1. Now the 1 we said had a multiplicity of 3, so we're going to go through. And then when we get over to the 5, it has a multiplicity of 1, so we're going to go through that one. And as long as I'm heading back to my end behavior, so then I have done the graph pretty good. So you can check that with Desmos if you want, but that should be good. All right, for number 2, it says, what's the difference between the forms? So it's walking us through graphing this. Now, the form that we just saw was already factored, okay? So this one is not factored. And that should be number 2. All right, so the end behavior, and the reason is a little bit easier, but the zeros will take a little bit more work. So for the end behavior, we're in x to the 4th. There's no, the lead coefficient is just a 1, so we're going to say that it's going to be both going up and that's because we have a positive lead coefficient and we are even degree. Okay, so to find the zeros or x-intercepts, we're going to make this whole thing equal to 0 and see what we can figure out here. So if I have 3 terms, the first thing that I always want to do is see if there's any common factor. So they actually all have x's, they actually all have x squared. So I'm going to factor that out. We'll be left with x squared plus 2x minus 8. Yeah. Let's see, I'm going to try and do some guess and check factoring. I need an x squared. That comes from x and x. I need to multiply to negative 8. That could be a 4 and a 2, but one of them needs to be negative. Now we remember that we also want to add to 2. So that would be a positive 4 then and a negative 2. So my zeros, I set each thing equal to 0. Some of you guys can do that just by looking at it, but it's nice to show this. So we're going to end up at x equals 0, negative 4, and 2. And then for their multiplicities, 0 happens twice because of the power 2. X plus 4 only happened one time, and the x minus 2 only happened one time, so that's the multiplicities for those zeros. We can list them as points. So we're looking at 0, 0, negative 4, 0, and also 2, 0 as our actual x-intercepts. If it has a multiplicity of 2, we know we bounce. Here we go through because it's odd, and also odd there. Our y-intercept, we put a 0 into the equation. Again, this one is a little bit nicer than when it's factored, actually. Just plug into the original function. So we'll take 0 to the 4th plus 2 times 0 to the 3rd minus 8 times 0 squared. That's just going to be 0. So we know we touch at 0, 0, which we could already have kind of seen that from our zeros that we got. So I'm going to put in my end behavior. Those are my goals to get to. I'm going to plot my intercept. So I'm at 0, 0, negative 4, 0, and also 2, 0. And I don't touch the y-axis anywhere except for 0, 0, so I already have that. So now when I go down to negative 4, we know we're going to go through that because we had that odd multiplicity. Sometime we got to come back up. We're going to go through 0, 0, but we're just going to bounce there. And we got to come back up to get that other 0, and we're going to go through because that had odd multiplicity. So something like that should work. All right, going on to number 3. So we're kind of doing the same thing again. Our end behavior, the highest power we have here is x to the 5th with a lead coefficient of 9. So we're going to look like an odd degreed polynomial, and it's in that direction. So we're odd degree, and we have a positive lead coefficient. All right, so to find the zeros, it's setting our equation equal to 0. So we have equal to 0. Oops, my bad. And we'll have 9x to the 5th plus 9x to the 4th minus 25x to the 3rd minus 25x squared. So again, the first thing I like to pull out is a GCF. They all have x squared, so I'll pull that out. We'll be left with 9x to the 3rd plus 9x squared minus 25x minus 25. Okay, so that's pulling out the GCF. Then next, when I look inside, I have 4 terms. And what we've been saying is we have 4 terms. Let's try grouping. So I'm going to rewrite 0 equals. We'll have the x squared still. And we're going to group. We're going to say these have a 9x squared in common. We're left with x plus 1. The next set have 25 in common. We're left with x plus 1. So x plus 1, I see both of those have that factor. I'm going to write that. And then I have 9x squared minus 25. The x squared will still follow from that original GCF. So I have that going on. Then I notice that this is the difference of 2 squares. So that will factor 3x plus 5, 3x minus 5. I have x plus 1 and x squared. So then my zeros, I'm going to end up with x equals 0. For the x plus 1, I'm going to x equals negative 1. For the 3x plus 5, that's going to be actually negative 5 over 3. So set that equal to 0, subtract 5, divide by 3. And then I'm also going to get the positive of that from that last factor. Now, the 0 has a multiplicity of 2, so that's going to be the one that bounces. The other ones all have a multiplicity of 1. So those are all going to go through. All right, so now my y-intercept, that's plugging a 0 in, and if you go back to, again, our original is the easiest. If you plug a 0 in, you're going to get 0. So 0, 0 is our y-intercept. So I'm going to plot the intercepts. I have the 0, 0. I have negative 1, 0. Negative 5/3 is actually an improper fraction. It's going to be negative 1 2/3. So really close to negative 2. And then 5/3 is going to be really close to positive 2 then. And again, my end behavior, I'm going to mark that. Okay, so those are my goals. The only one that I bounce off of is x equals 0. So that means everything else I'm going to go through. So I'm going to go through, and then go through, and I got to bounce, and then something was coming up. So something to that effect is what we should have for that sketch. Now, using our knowledge of the parent functions, what functions does a polynomial resemble at zeros with a multiplicity of 1, 2, and 3? So if it has a multiplicity of 1, if you were to zoom in, it looks like a line. You kind of see that guy. If it has a multiplicity of 2, you zoom in, and it looks like x squared. And then if it has a multiplicity of a 3, that's going to look more like x cubed. So multiplicity of 1, 2, and 3. And that's what we kind of talked about, that if you go through, you look like those lines. If you bounce, you look like our parabola. And similar for x cubed. So this is like x squared, and x cubed. All right, last one, number 4, it wants us to find all of the zeros with their multiplicities. So let's identify what's going on here. It looks like it's counting by halves, so this would be negative 1, negative 3, just trying to fill in some detail here. All right, so it looks like we have a 0 at negative 4, negative 3, negative 1, 2, and 4. And if I go back to each of them, it looks like our multiplicities. So if we're going to try and identify multiplicities, I'll write them in this other column here. Negative 4 looks like a line right there, so we'll say 1. Negative 3 has a 1. Negative 1 looks like 2. 2 looks like it could be a 1, maybe even a 3. And then that last one would also be a 1. So we're just trying to kind of write like the least degrees. So that's why I don't put anything higher. We just know that it's odd multiplicity just by the picture. So in factored form, using all of these zeros as well as the multiplicities, this is going to be x plus 4, x plus 3, x plus 1 squared because of that multiplicity, x minus 2, and x minus 4. Okay, now we don't know if this is like being stretched or anything, so we're going to stick that a in there that we've done before. And if you notice, it looks like, again, it's counting, it looks like maybe, and this is really estimating a little bit here, 0.75 is where our y-intercept is. So we're going to say then that f of 0 is equal to a times, put zeros in for all that stuff, and we think that this should be about 0.75. And so this is kind of rough. It's not so precise because I don't know where that y-intercept is, but I do know that I can find the a now. A times, so if I multiply out all of that stuff, I'm going to end up with 96. Is supposed to equal to 0.75. And actually, that's negative 0.75. Should have had that on my graph. So if I divide by 96, it looks like a should be about negative, I'm going to say about, this little squiggly equal sign, negative 0.008. And that would be the polynomial. All right, last thing. It says, what does the end behavior tell you about the first term? So based on, if I go back to my function, the end behavior is both going down. So that's telling me that I have an even degree and a negative lead coefficient. Now the minimum degree, well, because of the multiplicities, if you look at our multiplicities, our minimum degree would be the total of all of those, because we have to have all those factors. So if you think about multiplying them all out, we would have to have a degree of 6. And again, that's because of the total multiplicities that we had up there. But it could be different combos of that, because I could have, instead of saying like a multiplicity of 1, it could have been a multiplicity of 3. I really don't know what it was up there, but if I do it as written, that's what I would have there. All right, hope that helps.